Okay, so for this problem, we're going to be determining the probability when rolling two fair dice of getting a 7 or higher. Now, as is the case with many such questions, we're going to be determining the number of possibilities that meet our criteria and dividing that by the total number of possibilities. Now, to determine the total number of possibilities, what we have to do is establish a sample space. Now, before I start going on about sample spaces and events and so on, I'm going to say that this is going to be a little bit longer than your average "here is the answer." Instead, what I'm going to do is try to set up a way of tackling these kind of problems so that if they change it, you can still do it. So, our sample space that we have will be set of all dice pairs, D1, D2, where they come from the numbers 1 through 6. So specifically, we're not interested in a die that somehow, by some freak luck, lands like that. All of our dice will land like this and will have a face value. The reason why I'm pointing that out is because some people could ask, what is the probability of anything happening? Well, there's a lot of, the damn dice could explode, or there could be a nuclear explosion, or whatever. We're not interested about any of that. We just want to know about this damn dice problem. So, our outcomes of interest are the set of all pairs such that the numbers within those pairs that occupy those spaces D1 and D2 will come from the numbers through 1 and 6. Now, suppose you have 1 as the first number. How many possibilities are there for the second number? Well, there are 6. What about 2? There are also 6. What about 3? There are also 6. And so on and so forth. So really, you have a sample space that has a cardinality of 6 times 6, or 36. The cardinality, which this is what taking the cardinality of a set is essentially counting the elements inside of it. And so we've counted all of the pairs. So 1, 2, 1, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, and so on. And if you count them all, you get 36. So that's going to be the size of our sample space. Now, this probability here is going to wind up being the cardinality of our event divided by the cardinality of our sample space. So already we're half of the way there because we know what this is, which is fantastic. So our event of interest, that's this guy down here. Oh, just grab this one. Make them a little bigger and have them fit there. There we go. So it's the set of all D1, D2 such that D1 plus D2 is greater than or equal to 7. That is the formal way of writing it down. That is probably the way that you've seen it in class. There are ways you could write it down with words, and you could do it in all sorts of different ways, but I'm not going to baby you with less than the formal notation for these things. So our event is going to be the set of all pairs that meet our criteria, and our criteria is specifically that the sum is greater than or equal to 7. Now, to be able to tackle this, remember what we're interested in is what is the cardinality of this bad boy. So what we can do is actually partition this into sets where we have E1 all the way up to E6, and there are no overlapping elements between any of the elements inside of those sets. And so how are we going to do that? Well, we're going to see E1 is all of the outcomes which have 1 as the first value. And so 1 for D1, and then E2 will have 2 for D2, and E3 will have 3 for D3, and as you can tell by the way that we've defined it, there's no way for, let's say a 3-4 to be an E2 because 3 is not equal to 2. So formally, that definition is specifically this. So we've defined EI to be the D1, D2 pairs, such that D1 is equal to I, and D2 is in 1, 2, 3, 4, 5, 6, and I guess you could say I is also in 1 to 6, if you want to be completely rigorous. So we've got a whole bunch of sets, and let's see if we can count the number of elements inside them that match our criteria. So again, this I've already spoken about, so we don't need to talk about that. So E1 through E6 are the following sets. So you have one, E1's going to have a 1 here, E2's going to have a 2 here, E3's going to have a 3 here, and a 4, and a 5, and a 6. And then D2, well, what numbers can D2 be if the sum needs to be greater than or equal to 7? Well, in this case, it can only be 6. Okay? So this E1, the set E1 has 1 element in it. Okay? Now, if we go to E2, what numbers can it be? Well, since we have a 2 there, there's an additional number that can be allowed to happen, because 2 plus 5 is 7, 2 plus 6 is 8. Okay, and so our E2 is going to contain 2, 5, 2, 6. Okay, and I'll do this for one more, and then I'll shorten it. So this one will be 4, 5, 6. And so our E3 is going to be 3, 4, 3, 5, 3, 6. Okay? Now, as you can see, there's a trend. You have 6, then you have 5, 6, then you have 4, 5, 6. Now we're going to get 3, 4, 5, 6, 2, 3, 4, 5, 6. And in this one, it can be anything it wants to be, because the first number will be a 6, and so any dice roll will be fine for the second one. There we go. Okay, so what's the cardinality of E1? Well, if we look here, the cardinality, we're taking the cardinality of this guy. We count the number of elements in it, and so the cardinality of E1 is going to be 1. And how many elements are there in E2? Well, the cardinality of E2 is going to be 2. And how many elements are in E3? Well, cardinality is going to be 3. And we see the same pattern emerging, where cardinality of EI is going to be I. So really, we have that the cardinality of our outcome of interest, which is again defined up here as a set of all dice pairs where the sum is at least equal to 7, is going to be E1 plus E2, cardinality of E2, plus dot 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 dot, plus cardinality of E6, which is just going to be equal to 1, 2, 3, plus 4, plus 5, plus 6. And we don't need all this stuff. And now here we can use that formula if you want, the n times n plus 1 over 2. But formulas are scary, so we can just do the sum, since it's an actual easy one here, which is just going to be 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, 15 plus 6 is 21. So our probability of E, which is equal to the cardinality of E, the number of possibilities of getting dice rolls that meet our criteria, divided by the total number of possibilities of dice roll, is going to be 21 over 36. Which you can probably reduce if you divide by 3, which would give us 7 over 12.